Hello there, everyone, and welcome to the session with me, Melissa, the in-house maths teacher at ICS Learn. My details, as always, are there on the screen if you need to get in touch with me. We also have Ailey Somerton, who's one of our tutors here at ICS Learn. So if Ailey's your tutor, please do say hello. I'll just unmute Ailey for a moment just so that she can say hello to you. So just give me a second while I do that. Hi there, Ailey.
Hi. Yes, can you hear me?
We can hear.
Yeah, good. Well, hi everybody. I think I recognise a few of the names in the chat box, so I'm here to answer your queries while Melissa's talking. So, any questions about what Melissa's talking about or anything else, just write it in the chat box, and I'll answer you there. Okay. Enjoy the lesson.
Thank you, Ailey. It's always good to have an extra pair of hands when it's busy. It means that I can just concentrate on talking through the slides while Ailey answers all of your questions there in the chat box. And also, if she's your tutor, it will give you an opportunity to speak to her a little bit there as well. Okay, so today we're going to cover decimals, obviously a very big topic because our number system is based on decimals, but I'll do my best to cover the basics and to give you some pointers for where you can go to get extra practice questions if you need to. I mean, obviously, if the content is already very familiar to you, you won't need to spend too much time on it, but if it's something that you feel you really do need to brush up on, then please use the links that I'm going to give you. So I always suggest that you make some notes as you go through. If you're watching the live session, don't worry about this too much. But for those of you watching the recorded version, certainly writing notes will really help you when you're doing revision later on. Now, I am going to demonstrate a few things using the calculator. The one that we recommend at the moment is the Casio FX85GTX. So that's usually the one that I'll be referring to. There is an older model, the GT Plus, so if that's the one you've got, they work in practically the same way. There's not really very much difference between them. So it will help if you have that with you in front of you now. If you don't have it there, don't worry too much if you're watching the live session. You can always have a go at some of the things I'm showing you later on. So, an overview of what I hope to cover today, hopefully with 1 hour. We'll talk about place value and how to order decimals. We'll look at converting between decimals and fractions, multiplying between 10, 100, 1,000. Those are sometimes called powers of 10. And then we'll look at some arithmetic using decimals. Now, I've briefly covered multiplying and dividing in my first session with whole numbers, but now we'll extend that to multiplying and dividing decimals. And we'll also take a quick look at adding and subtracting decimals, which I hope is already quite familiar to you, so I won't spend too long on that topic. So first of all, let's look at what decimals are and what we mean by place value and basically how our number system works. So decimals are used to show fractions of a whole number or parts of a whole number, and they're based on tenths, hundredths, thousands. You're probably very familiar with decimals already because you work with them with money. That's probably the most common context. And also things like measurements will be using the decimal number system on the whole if you're using metric. So supposing I have a number like this. Now our number place value system is very clever because it allows us to use just 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, to make any number depending on what position it's in the number. So here's a number. There's a 6, a 2, a 7, a 3, an 8, and the 1. But the way that I read that out will tell me what those digits are worth depending on where they are. So this dot here is the decimal point, and that divides the whole number part from the decimal part. So the way I read this out, you do it automatically without even thinking about it, is that we know that the 6 in this position is worth 600. The 2 in this position is worth 2 tens or 20. We've got 7, and then we've got a decimal point. We've got 3 tenths, 8 hundredths, and 1,000. So when you read out a number like this, you would say 627.381. Don't say 381 because it's not worth 381. You just say that the digit's 381, like that. Okay. So we've got the decimal point there separating the whole numbers from the fractional numbers. An extension of the place value grid might look something like this. So the way it works is that each position in the place value grid, if you go in this direction, they're 10 times bigger. Each position, so we've got 1. 10 times bigger than 1 is 10. 10 times bigger than that is 100, and we've got 1,000, and we've got 10,000. So we're just adding a 0 each time to move it along the place value grid. And if we went back in the other direction, so we're going back the way, if we start at 10,000 and go down, we've got 1,100, divide by 10, 10, divide by 10, 1, divide by 10, 0.1, 0.01, and so on, going all the way down. So these are tenths, hundredths, 10 times less than that, or divide by 10 gives us thousands, and so on. And it can go on infinitely in either direction. I've also included here powers of 10. So sometimes these are called powers of 10 because it's 10 to the power of something. 10 to the power of 0 is 1, 10 to the power of 1 is just 10, 10 to the power of 2 or 10 squared is 100, 10 to the power of 3 is 1000, and so on. And we will go back to these later on when we do standard form in Unit 3. So it helps to be familiar with them. And we'll also cover indices in general later on in the course, but that's why I've included those numbers there across the top. Now, sometimes in the exam, in the very early parts of the exam, you might be given a number like this, and you might be asked to say, what is the value of the digit, the 6? What's the value of the 7? What's the value of the 8? And what they're asking you to do is to think about the place value. So in this example, the 6 is in the hundreds position. So that 6 is worth 600 in that position. The 2 is worth 20. The 7 is worth 7 units, or just 7. The 3 is worth 3 tenths, or 3 over 10 written as a fraction like this. The 8 is worth 8 hundredths, and the 1 is worth 1,000th. So if it's 3 places away from the decimal point, the further away it is from the decimal point, the smaller it is, or the less it's worth. So you could have a 9 here and a 1 here, and the 9 would be worth less than the 1 because it's in a different position in the place value grid. So always have the place value grid in mind when you're thinking of numbers, when you're adding and subtracting numbers, and also when you're multiplying and dividing by 10, 100, and 1,000. And you'll see in a minute why that helps. Now, the first thing that we're going to talk about, though, is how to order decimals. Now, it's not as easy to order decimals as it is to order whole numbers. And that's because adding zeros on the end of a decimal doesn't change its value. Once it's past the decimal point, you can put as many zeros as you want afterwards and it won't make it worth anything different. So we could have a situation where we've got a number like 5.6 and a number like 5.599, and this number is actually smaller than this number, even though it's got more digits in it. So that's the first thing to realize. That's the main difference between comparing the sizes of whole numbers and comparing the sizes of decimals. So how do we order them? Now, all of these all start with 5, so they're all 5 point something. Here's a method. There are two methods I'm going to show you. They're kind of similar, but here's the official method, the best way to do it. So what I'm going to do here is I'm going to write the numbers just in the order that they're shown there. If you've already got the answer and you want to type it into the chat box, that's fine. Ailey will tell you if you've got it right or not. So I'm just going to list them all in order like this, lined up. So all of the decimal points are lined up, the tenths are lined up, the hundredths are lined up, and the thousandths are lined up. And once you've done that, it might be helpful then to put some zeros in the missing spaces. So I'm then just going to fill those missing spaces with zeros. Then the next thing I'm going to do is look at each digit in turn, starting from left to right. And the reason I start with the digits on the left is that they're worth more. So all of these 5s are worth 5 units. That doesn't help me when it comes to ordering it because they're all the same. So the next thing I need to do is look at the next digit along, look at the tenths. So how many tenths have I got for each one of these numbers? So here I've got 5 tenths, 6 tenths, 5 tenths, 5 tenths, 6 tenths. So the numbers with 5 tenths are smaller than the numbers with 6 tenths. So I've got these 3 numbers here are the 3 smallest numbers. But they've all got a 5 in the tenths position, so I then need to compare the number in the hundreds position. So here I've got a 9, a 7, and a 9. So this is my smallest number, 5.57. So I can write that down. And as you write them down, I would cross them off the list just so that you know which ones you've done, because it's easy to lose track if you've got quite a few numbers. So that's my smallest number there, 5.57. Now, These next two numbers along, they've both got 9, so I'm going to go to the next decimal point, and I've got a 9 here and a 6 here. So the next digit along, the next smallest one, is 5.596. So I'm going to cross that out, and I'm going to write it down on in my list in order. You don't need to include the zeros on the end there just to help keep things lined up. So the next one then is going to be the 5.99. That was the next one that we had. And then lastly, we're going to compare the two that start with 5.6. So this one is 5.61 and this one is 5.60. So this one is smaller than this one. So those are my last two, and I just add them there onto the list. Okay, so that's my final list in the correct order. Another way of doing it, which you might find easier, is kind of an unofficial way of doing it. If you put the zeros in so that all of the decimals have the same number of digits after the decimal point, you could then think of them as if they were whole numbers. So this is like 599, this is like 610, this is like 570, this is like 596, and this is like 600. So by thinking of them that way, although they're not actually worth whole numbers, you're much more used to ordering whole numbers. That will make it much more easy then, be much easier then, because you know that 570 is the smallest, then 599, oh sorry, then 596, then 599, then 600, and then 610. And it will also distract you from the fact that they have different numbers of digits after the decimal point. So putting in the zeros there so they're all of the same number of digits will always be the first step. Okay, now hopefully that helps. There's some more examples in the textbook and in the CIMT sheet, which I'm going to give you, but that's the method that you're going to use when you're doing problems like this. So if you have a look at this interactive worksheet, this is just a quick exercise, a warm-up exercise before you start working through some of the harder questions. If you click on that link in the chat box, if you're watching the recorded version, you'll need to click on chat. Click on view, click on chat, and then you should be able to click that link or copy and paste it, or depending on what browser you're using, right click and then click on that, and it should open up for you. If you're watching a YouTube recording of this, it will be in the links underneath the video. Okay, so have a go at these questions. Next, I want to have a look at how you convert between decimals and fractions. So all decimals can be written as fractions using the place value system. So you can convert what we call a terminating decimal. So a terminating decimal is a decimal that's got a fixed number of digits after the decimal point. Now, if your decimal has got one digit after the decimal point, then you can just write it as a fraction over 10, because that one digit after the decimal point is the number of tenths. So for example, if we had 0.8, we could write that as 8 tenths, 8 over 10. Remember to cancel the fraction down if you can. So remember, when we cancel a fraction down, we're looking for a number that divides into the top number and the bottom number. 8 and 10 are both even numbers, so they can both be divided by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So that means that 0.8 is the same as 4/5, like that. So that's the main thing to look out for, is common factors when you're writing these. Now, if your decimal has got two digits after the decimal point, write it over 100. So for example, if we had 0.45, we could write that as 45 over 100. A way to remember it is 100's got two zeros and there are two digits after the decimal point there. Cancel if you can. So both of these numbers can be divided by 5, because 45 ends in 5 and 100 ends in a 0. 45 divided by 5 is 9. I'm just giving people who want to answer the question in the chat box some time to answer the question. 45 divided by 5 is 9, and then 100 divided by 5 is 20. So 45 hundredths is the same as 9 20ths. One more example of these. So if there are 3 digits after the decimal point, write the number over 1,000. So here we've got an example, 0.048. So that's 48 over 1,000. Can that cancel? A bit harder to cancel, but it looks like it does. Now, 1,000 can be divided by 4, half a thousand is 500, half of 500 is 250. So we could try that first. We could do it in stages. You might spot that it can both top and bottom can be divided by 8. It doesn't matter if it takes you more steps. If you're in a non-calculator exam and you don't spot straight away what the highest common factor is, don't worry, just do it in stages. So let's cancel this down by dividing top and bottom by 4. So if we don't divide top and bottom by 4, we get 12 over 250. And you can probably divide by 4 in your head by halving and halving again. And both of those numbers are even numbers, so we could possibly half them again. So that would give us 6 over 125. Now, this is a 6 and this ends in a 5, so they don't share any common factors. I've now simplified this as far as it can be simplified. So 0.048 is the same as 6 over 125, 625ths. Now, if you want to convert a decimal to a fraction using your calculator, it's really easy, especially if it's set to show all answers as fractions where possible. So all you need to do is type in, I've got my calculator here, though you probably won't be able to see it on my webcam, but all you need to do is type the number, the decimal, into your calculator, so 0.048, for example, and then press equals. And the calculator will just convert that then into a fraction for you. So for example, to convert 0.625 into a fraction, just type in 0.625 and press equals. If you've got a different type of calculator, it might not do it that way. You would have to refer to your instruction manual to see how it works. So let me know if that works for you. Hopefully it does. If it's not working for you, contact me or your tutor and we'll have a look at what calculator you've got. So we'll show it like this. 5/8, 5 over 8. Now, there is also a function on your calculator, this is a little bit more advanced, to convert what we call a recurring decimal into a fraction. So you might have seen decimals that are written with dots above, or you might know of fractions. So for example, if you have the fraction, the decimal 0.33333, where the threes go on forever, that's what we call a recurring decimal. And there will be a dot on top of the 3 that shows that the 3's go on forever. Here's another example. So supposing we want to convert the decimal 0.43 with a dot on the top into a fraction. If you're doing foundation tier, you'll only ever do this with a calculator. If you're doing higher tier, there is a method to convert a recurring decimal into a fraction, but it involves some algebra. So you won't do that unless you're working towards the higher tier exam, and that'll be covered in Unit 4. But for now, if you do have a fraction like this and you want to convert it into a fraction using your calculator, what you need to do is press Shift on your calculator and use this, there's like a box with a dot on top above the X squared button. So to convert something like 0.43 recurring, that's another way of saying 0.43333333, where the 3's go on forever. So on your calculator, type in 0.4, then Shift, then the X squared button. I'm assuming you're using one of these Casio calculators, and then 3. That will put it in the little box, and then press equals. And your calculator, I'm seeing some correct answers there, so I'm assuming you did that using your calculator rather than using the algebraic method. Will show you 13 over 30. So excellent, Amy and Lydia and Rebecca, for working out how to do that on your calculator. That'll be very helpful later on when you're converting things like thirds and sixths. Can get a little bit awkward because they don't divide exactly into tenths. So multiples of 3 can be awkward and multiples of 7 can be even more awkward, but we'll do some more work on that later on. So if you want to practice doing this, there's some quick practice questions here. I like these worksheets because you just type the answer into the box and it tells you straight away whether you're right or wrong. So have a go at some of these questions here and let me know how you get on. You can also find some questions within your course materials in the decimals section of Unit 1. I'll give you a link to that page, but you should be able to find it by now. So just go to My Learning, go to Unit 1, and you should find the decimals section in there. Okay, how to convert fractions to decimals. Now, here's where it can get a little bit more difficult because you'll use different methods depending on what fractions you're starting with. But basically, the thing to remember is that you can convert a fraction to a decimal using division. So We can either do that with a calculator, which is the way we probably would do it most often, or you can use a written method like short division. That's unlikely to come up in the exam, but it's possible. Most of the common conversions you will just learn off by heart and recognize them, or just take out your calculator in most cases. So here are the most common fraction to decimal conversions. So these are the things that I would say is worth just learning how to convert between. So some of them you know already from place value. So for example, 100th, you should know what 100th is. Similarly, you should know what 200ths are, 300ths are, 400ths are, 500ths are, because it's just 0 point and the number. So 0.0 and the number because it's in the hundredths position. So learn that 100th is 0.1, and that will then tell you that 300ths is 0.03. So I might have said 0.1, but I meant 0.01, and so on. So that's a very helpful conversion for you to remember. Similarly for 1/10 you should just learn is 0.1. That's what we mean by 1/10. Then we've got 1/8. Now 1/8 is a little bit tricky to remember, but as you work through, you might come across it. So 1/8 is 0.125. These are related to percentages, so you'll be learning the percentage equivalent as well. And if you're wondering where that number comes from, you could maybe think of it as if you've got 100 and you find half of 100, that's 50. If you find half of 50, that's 25. That's where the quarter comes from, 0.25. And if you half 25, you get 12 and a half, and that's where those digits come from, the 125, but obviously with the decimal point moved on a little bit. So that's 1/8. 1/5 is the same as 2/10. So because 1/5 is the same as 2/10, that will give us 0.2. So 0.2 is the same as 1/5. A quarter, hopefully you know what that is. Use the chat box if you want to. Someone's asking about how to convert to percentage. We will do percentages next session, but I'll just tell you very quickly, you just multiply the decimal by 100. If you multiply the decimal by 100, that will give you the percentage. So for 1/4, we've got 0.25. You could think of it in terms of money as well. That might help. So you know that 25 pence is quarter of £1. So that's where that comes from. So 0.25. 3/10, what would that be? Well, just as an example, because we know that 1/10 is 0.1. So what would 3/10 be? And similarly, if you had 7/10 and so on. So that's 0.3. So that's worth remembering. Then an interesting one is 1/3. So 1/3, I think I already briefly mentioned when I was talking about the calculator, that is equal to 0.3 recurring. That's what that dot means. It means recurring. So 0.333333333, where the threes go on forever. And that's because if I try to divide 1 by 3, I always got a remainder. If I try to do the division, it just doesn't ever end. So the threes go on forever. And that dot above the number tells you that. Be very careful because 0.3 and 0.3 recurring are not the same number. They're different because this is a terminating decimal where I've just got one digit after the decimal point. This number is bigger because there's another 3 after that and another 3 after that. I can never write it exactly as a decimal unless I use this dot to say that that 3 goes on forever. Does that make sense? So these are different numbers. How about 2/5? That's quite nicer looking one, I hope. You don't really need to learn this one, but it's just to show you the point that if I know that 1/5 is 0.2, then 2/5 is going to be double that. So that's 0.4. Well done, Lydia and Hannah and Amy. Good. 0.4. Let's try a couple more. How about a half? Do you know what a half is as a decimal? Hopefully you do. Think of measurements. So if I've got 1.5 meters, that would be 1.5 meters. So a half is 0.5. So 0.5 means a half. How about 2/3? Okay, that's a little bit more tricky, but if you know that 1/3 is 0.33333 with the threes going on forever, what do you think 2/3 will be? Good, Hannah, you've just written it. You can't do the dot on in the chat box. So it's just 0.6666666 with the sixes going on forever. But a better way to write it is with a dot above it. Note again, 0.6 recurring, where the 6 is going on forever, is different from 0.6. 0.6 means 6/10 or 3/5, whereas 0.6 recurring, if you're rounding it, it might be written as 0.67 or 0.667. We'll go on to rounding in a different session. But for now, either just this is less mathematical with the dots at the end. You can write it like that, though. That's fine. We would know what you mean. Or write it with a dot above the 6. And then one more is 3/4. Means the same as 3 divided by 4. We know that 1/4 is 0.25. So 3/4 is 3 times that. 25 plus 25 plus 25 is 75. So 0.25 plus 0.25 plus 0.25 is 0.75. And that means 3/4. Okay, so try to learn those, or at least become familiar with these conversions as you work through the course materials. Um, I'm going to show you how to do it on a calculator then. So to convert a fraction to a decimal using your calculator, all you need to do is divide the top number by the bottom number, because that's what that means. So 4/11 or 4/11ths means the same as 4 divided by 11. So on your calculator, type in 4 divided by 11 equals. If you want to try that now and type your answer in the chat box. We'll see if you're right. I will reveal the answer in just a second. Now, if you're using the Casio calculator, you might spot that the calculator just says 4/11ths because it's just giving you the answer as a fraction. So what you need to do is use this S to D key. So you change the fraction into a decimal using this S to D key if you're using that kind of calculator. The calculator's not gone mad, it's just telling you the same number in a different form, and it defaults usually to fractions. So if you do get this answer, 4/11, just press the S to D key and it will just change it into 0.36. Note the dots above the 3 and the 6. So what that means when you've got a dot above the 3 and a dot above the 6 is that it's a repeating cycle where the dot above the first digit in the cycle and the second dot is over the second digit in the cycle. So this one would be written as 0.3636363636 going on forever. If you want to convert it, you again press the S to D button again and it should write it that way. So 0.3636363636 forever, going on forever. Try it with some other examples and see what you get. You'll always either get a terminating decimal or recurring decimal when you're converting a fraction to a decimal using your calculator, as all fractions are. There is such a thing as an irrational number, which doesn't convert into an exact decimal, but we're not going to cover that just now. That's a much more advanced idea. Okay, so that's what you should see if you press the S to D button again. Now, if you don't have a calculator or you have a question in a non-calculator paper, you can use short division. I'm going to show you how that works. So for example, supposing we wanted to convert 3/8 into a decimal, first of all using the calculator and then using short division. How do you divide 3 by 8 using short division? Let me show you. If you're just using the calculator, you just do 3 divided by 8 and that will give you 0.375. Press the S to D key if you need to. For short division, what we're going to do now, you might think, oh, how am I going to divide a smaller number by a bigger number? That doesn't make sense. Well, you can do it. And the way that you do it is by writing the 3 as 3.000, putting as many zeros as you want after it. You're going to get a number that starts 0 point something if it's a fraction like this that's less than 1. But that's fine. We can do that. So set it out like this. So we're doing 3 divided by 8. So if you're using this, sometimes called bus stop method, put the 8 on the outside because that's the number that we're dividing by, and the number that's being divided goes under the division sign like this. Now I know it's going to be 0 point something, so I'm just going to add some zeros there after the decimal point. And then just go through the steps as you normally would. So you do 8 into 3. I did demonstrate this briefly in the first session on calculation, so revisit that if you need to. So I do 8 into 3. Because 3 is smaller than 8, it doesn't go any time, so I put a 0 above the 3. And then the remainder is 3, so I'm going to carry the 3 and put it next to the next 0 along. Line up the decimal point, so the decimal point just goes here after the first 0. And then here I've now got 30. So here's where you need to know your 8 times table. 8 into 30. Does anyone know what that goes 3 times. 3 times 8 is 24. So I put 3 above the 30. 30 minus 24 is 6, so the remainder is 6. So I carry the 6 onto the next column. So I've put the 6 across, so that then gives me 60. So I then need to work out 60 divided by 8. 60 divided by 8 is 7. 7 times 8 is 56, so the remainder is 4. So I put a 7 above the 60, and I carry the 4. And then I've got a 40 in the last position here. Now, I've put 3 zeros here because I knew that my answer was going to have 3 digits after the decimal point. But if you were trying to convert something like, say, 1/7, and you didn't know how many digits you were going to need, you would just keep putting zeros. So you can just keep putting zeros, and if it's a recurring decimal, that might even go on forever until you notice the repeating pattern. So you can just keep adding zeros because, as I've said before, you're not changing the value of a decimal by putting zeros on the end. So the last digit here is a 5, and that agrees with the answer that we found earlier. So that's how you would do it using short division. There is one more method that I'm going to show you. We're just doing the reverse of what we did earlier. If you have the denominator of a fraction as 10, 100, or 1,000, then you can convert it the other way that we did earlier using the place value fact. So just remember that 1/10 is 0.1, a 100th is 0.01, and a thousandth is 0.001. So we just put the numerator digits in the right decimal places. Let me show you what I mean by that. So for example, if I had 135 thousandths, a thousand thousandths is one whole one. So I've got 0 in the thousands position, and then these other digits fall into place. So this digit will be in the thousands position, tenths, thousands, hundredths, tenths. So this will look like 0.135 if I convert it into a decimal. Another way you could think of it is as 135 divided by 1,000. I'm going to show you how to divide by 1,000 in a moment, but that would mean imagining a decimal point at the end here. Dividing by 1,000 means moving that decimal point 3 places to the left. 1, 2, 3. Again, 0.135. So that's another way of working it out. Now, sometimes, all of these examples here have already got 10, 100, and 1,000 on the bottom. So the important thing to remember is that the digits on the top don't change. You just need to figure out the place value. So the first one here is 6/10. How do we write that as a decimal? Well, the 6 is in the tenths column for a decimal, so that's just 0.6. If I've got 3 hundredths, it just means a 3 in the hundredths position. Or think of it as 3 divided by 100, so that gives you 0.03. How about this last one? Now this time I've got 67,000, so it's the 7 that goes into the thousandth position. This 6 will go in the hundredths position, and then I don't have anything in the tenth position, so that I need to put a 0 there just to hold the place value. So that would be written as 0.067, or as before, just think of it as 67 divided by 1,000. Sometimes the quickest way of doing it would be to rewrite the fraction so that it's got 10, 100, or 1,000 on the bottom. You can't do that with all fractions, but if it's something like 50, then I can just multiply top and bottom of that fraction by 2, and that will give me an equivalent fraction over 100. So sometimes I might need to do a little bit of manipulation. So before you start doing something like long division or short division, think about whether the bottom number of your fraction can be divided into 10, 100, or 1,000. So this one can be, I've got 50 on the bottom, so I'm going to double top and bottom to write it as a fraction over, in this case, 100. So if I double top and bottom, I get 100 on the bottom and 44 on the top. And once it's written in this form, it's quite easy to change into a decimal. That will just give me 44 hundredths, which is 0.44. Junaid, you won't need to do long division in the exam, and I doubt that you would even have to convert a fraction into a decimal using short division. Mostly it would be the ones that I've already shown you that you've already learned off by heart. Might be a simple fraction, like 3/8. I would hope that you'd be able to convert without using a calculator, but nothing more difficult than that. That would be the most difficult one that you would need to convert. Now, here is a summary of the three different methods. This is actually just a screen grab from the page in your textbook that's included with your course materials. So I'm just going to give you a link to that. Hopefully you've already set that up. So set that up on the resources page if you haven't done it already. And if you want to print out that page and keep that to remind you of the different methods, then you can do that. Now, the way that they've set out this division is a bit more like a long division, but don't worry about it too much. You can just use the short division method that I've shown you. Okay. There's also some practice questions in your course notes in the fractions section, actually at the end, converting fractions to decimals. So converting fractions to decimals is a bit more difficult, I think, than converting decimals to fractions. But practice makes perfect, so please just have a go at some of those questions. Now, the next thing I want to go through is how to multiply and divide numbers using 10, 100, and 1,000. And because of the way our place value system works, it's quite easy to multiply things by 10, 100, and 1,000 and divide them by 10, 100, and 1,000 because we're just moving the digits on the place value grid. So the digits themselves don't change. What we change is where zeros are placed and where the decimal point is placed to change the value of the number. Now, when you multiply whole numbers and decimals by 10, 100, or 1,000, or 10,000 or a million or any other number, but we'll focus on these ones for now, we move the digits to the left on a place value grid. Don't get confused between where I'm moving the decimal point and where I'm moving the digits. I'll show you what I mean with the place value grid in just a second. So if I multiply it by 10, each digit moves one place to the left. So that means that tens become hundreds, hundreds become thousands, thousands become 10,000, so on. That's what happens when I move each digit to the left on the place value grid. If I multiply by 100, I move each digit 2 places to the left. If it was a whole number, I could just add 2 zeros or add 1 zero for multiplying by 10, but with decimals, it works in a bit of a different way. And for multiplying by 1,000, I move the digits 3 places to the left on the place value grid. So the effect of that is that the decimal point, as I move the digits to the left, the decimal point moves to the right. Don't worry too much about the left and right because you'll know whether you're making the number bigger or smaller. Obviously, 47, if I make that 10 times bigger, becomes 470. If I make it 10 times smaller, it becomes 4.7. So don't worry too much about the direction. Just remember that as you move the decimal point or the digits, you're making the numbers 10, 100, or 1,000 times bigger. So for example, supposing I asked you to work out 4.701 multiplied by 100. So I know that the digits will be the same, 4701, but the digits are all going to get bigger by moving on a place value grid. So if I imagine them, I wouldn't normally write this out obviously, but if I imagine it on the place value grid like this, so the 4 is worth 1 unit, the 7 is worth 7 tenths, no hundredths, and 1,000. I should probably say 4 units is worth 4. And if I move all those digits on my place value grid one place to the left, that's going to make that number 10 times bigger. So it becomes 47.01. If I move the digits another place to the left, then the 4 is now worth 400. The 7 is worth 70. The 0, I've got no units now, and then 1/10. So the answer is 470.1. Another way you could maybe think of it is say, well, this is 4 and a bit times 100. 4 times 100 is 400. And then you just put the other digits in to follow on from that, putting in the decimal point where you need to. You could also think of it as moving the decimal point 2 places to the right. So if I've got the decimal point there and I move it 1, 2 places, it will end up between the 0 and the 1. The reason I'm moving it 2 places is because there are 2 zeros after the 1 here in 100. So here's a couple more examples. 0.392 times 100. So again, I'm moving the digits 2 places to the left, so the decimal point moves 2 places to the right, so it ends up between the 9 and the 2. I don't need the 0 on the front anymore, and that gives me 39.2. So with whole numbers, I don't include the 0 at the front, and with decimals, I don't include the 0 at the end. And part B is 7.28 times 1000. So imagine moving the decimal point 3 places this time, because I've got 3 digits after the decimal point. I'm seeing lots of correct answers popping up in the chat box there, so well done, everyone. So if I move that 3 places, 1, 2, 3, I've got a gap in on the end, so I need to put a 0 in that gap just to keep the place value of that number. So that will give me 7,280. Okay, how about dividing? So with dividing, it's the opposite. So with dividing, we move the digits to the right on the place value grid. Decimal point goes to the left. So to divide by 10, move 1 place to the right. Divide by 100, move 2 places to the right. Divide by 1,000, move 3 places to the right. And as I mentioned, that has the effect. So the digits go that way, the decimal point goes the other way. You're probably looking at a mirror image of me in the webcam, so I could be pointing in a different direction, but that's right for me. So supposing we wanted to work out 535.2 divided by 100. So I'm making this 100 times smaller this time. So if I'm making it smaller, then the decimal point is going to go this way now to the left. So if I move it 1 place to the left, 2 places to the left, the number becomes 5.352. So the digits stay the same. You only add zeros if you need to keep the place value, and you move the decimal point. So if we move the digits 2 places to the right in the place value grid, so imagine the number in the place value grid. If I move it 1 place to the right, I end up with 53.52. 2 places to the right gives me 5.352. So that's why the digits are moving to the right, but the decimal point is moving to the left. As I said, don't worry about the left and right thing too much. You should know intuitively whether you're making your number bigger or smaller. Okay, and then part B, we've got 80.09 divided by 1000. So divided by 1000 means it's getting smaller. So I'm going to move the decimal point this way. So 1, 2, 3. Now I've got a gap in front of the 8, so I need to put a 0 in there. I also need to put a 0 in front of the decimal point. I guess you could ignore that 0 in the front, but we make sure that there is a 0 in the front, because sometimes a dot can't be very clear. So that will give me 0.0809. Happy with that? Now, I know in some other countries they might use commas for decimal points, but I would urge you to try and do it in using the UK way when you're doing the exam, because it might cause confusion. So try to stick to using decimal points rather than commas. Now we've got a section multiplying, dividing by powers of 10. So powers of 10 just means 10 to the power of 1 is 10, 10 to the power of 2 is 100, 10 to the power of 3 is 1,000, and so on. So that's why we call those numbers powers of 10. So that's just a quick way of saying multiplying, dividing by 10, 100,000, 10,000, and so on. So there's a link there to that page. Let's have a look now at adding and subtracting decimals. So hopefully this is a method that you're familiar with from your previous learning in maths. The main thing to remember is making sure that all of the numbers in your calculation have the same number of digits after the decimal point, and lining up the decimal points. I think that's the biggest place that people go wrong. So make sure it's nice and neat, make sure everything's lined up. You can only add units with units, tens with tens, tenths with tenths, hundreds with hundreds. So supposing I had to add together these two numbers without using a calculator. I've got 9.8 and I've got 46.59. This number's got 2 digits after the decimal point, and this one's only got 1. So the first thing I would do is add a 0 to the end of this to make it 9.80, and that will make it much easier to add together. So if we first of all line up the decimal points, that's what I'm adding. These are units, so I add units to units. These are tens, these are tenths, and these are hundreds. So I'm going to put a 0 in here just to keep it nice and tidy. So fill any gaps with zeros, and then just add together in the usual way, starting with the numbers on the left column. Sorry, now I'm mixing up my left and right. The column furthest to the right, and then going through and carrying across as you need to. So for the first column here, I've got 0 plus 9. 0 plus 9 is just 9, so I write a 9 in here. Then I've got 8 plus 5. So 8 plus 5 is 13. Remember, always carry the digit in the next column along. So 13, I would put the 1 here and the 3 here. So it's in the same order. I don't swap the tens and the units round. So 13 is 1, 3. So 1 here and the 3 goes here. So carry the 1 along to the next column. Then we've got 9 plus 6 plus the 1 that I just carried. That gives me 16. So I write down the 6. 1 is the one I carry, and then 6. So 1 here and 6 here, so that the digits are kept in the right order. And then lastly, 4 plus 1 is 5. So that's my addition there, 56.39. Check it on your calculator to make sure you've done it right. That's always good practice. And that's my final answer. Now, subtracting decimals can get quite difficult, and for that reason, I'm going to show you two methods. Because if you're not someone that's been at school quite recently and you haven't done lots of practice of subtraction using the column method, it can be quite tricky to remember how to do it. So if you're not used to this method, I'll show you a different way that you can do it. So in this question, we want to find the value of 5.02 subtract 0.743 without using a calculator. It's tricky using the column method for this one because we've got zeros on the top, so we need to borrow numbers. Hopefully you've done this before at some point, so it won't seem too unfamiliar, but you might be rusty if you haven't done it for a while. So I'm going to put, first of all, as before, 0 in any gap and line up the decimal points. Then what you need to do is subtract, moving along from right to left. If the top number is smaller than the bottom number, then you need to borrow from the next column along. I'll show you how that works. So here we want to work out 0 subtract 3. So because 0 is smaller than 3, we can't use negative numbers here. We've got to borrow from the next column along. So I'm going to borrow. This, remember, is worth a thousandth. This is worth a tenth. So what I'm effectively doing here is borrowing a tenth. So that will then give me a 1 here, so we're worth 10 of those effectively. So that will be, the 2 becomes a 1, and then this will become a 10. So I've borrowed 1 like that. Then I work out 10 subtract 3. So I can do it now. So 10 subtract 3 is 7. Next, I've got 1 minus 4. So I'm going to have to borrow again. Now here's where it gets tricky because the next column is 0. So I can't borrow from 0, so I need to go to the next column. So I'm going to borrow 1 from the 5, so the 5 becomes a 4. Then this becomes a 10, because I borrowed 1, so I put the 1 there to make that become a 10. Then I'm going to borrow for this one, so the 10 then becomes a 9, and this will become 11, like that. So I can now work out what I'm really doing here, if you think about it, is I'm borrowing from the next place value along. So when I'm borrowing from the next column, I'm borrowing from a number that's 10 times bigger. So I'm not really borrowing 1, I'm borrowing 10 from the next one along. That's why it works. So here I've got 11 minus 4. I can work it all out now. So 11 minus 4 is 7. 9 minus 7 is 2. And then 4 minus 0 is 4. So the final answer is 4.277. And if you're comfortable with method, use it, then that's fine. I think it's quite difficult, really, if you haven't done subtraction in a long time. So it's much easier to add than it is to subtract. So what might be a much better way of working this out? And it's probably something that you do already when you're subtracting money and things like that, is it's probably easier to count up from 0.743, start at 0.743 and go up to 5.02. That's probably the way you would do it. If I asked you to do 100 subtract 73, you would probably start at 73. Well, you might not, but I think I probably would start at 73 and I say, okay, right, if I start at 73 and add on 7, that takes me to 80, and then add on another 20, so it's 27. So I think often an easier way to subtract is actually to start at the smaller number and count up. So I'm just going to quickly show you a way that you could set that out in a way that would make it easy to work out. And you can do it this way in the exam. You don't have to use a column method if you find that confusing. So the way I would set this out is I would draw a number line like this. I would put my starting number, which is the smaller number that I'm subtracting, at the beginning of the number line. And then I would think, right, I'm going to go up in jumps, and I'm counting up to 5.02. I mean, you do have to be quite familiar with decimals like this, but they work in a similar way to whole numbers. So if I start at 0.743 and I add on 0.007, that will take me to 0.75. So I could do that. I could do a jump. So we'll just write that out. So what I'm adding on is 700s here, 0.007, and that gives me 0.75. Don't need the O on the end. Or if you thought of that as 743 and you added on 7, I'm doing a very similar thing. Okay, that's already a simpler number. If I added on 0.25 onto there, just as if I added 25 to 75, that would take me to 1. So I could jump up a little bit more like this, 0.25, and that would take me to 1. I'm trying to get to 5.02, but from 1, well, I could go up 4, and that would take me to 5. So if I went up 4.02, try to do as big a jump as you can in your head. If I went up 4.02, that would take me to 5.02. So what you're trying to do is you're trying to jump up. You could go one digit at a time, jump up to the next one until you get to the number that you're trying to count up to. And then the way that I work out the answer, what's the difference between this number and this number? What you're doing is you're adding up the size of the jumps. So here are the 3 jumps I made. You might have needed to make more jumps, but I was happy working with those in my head. And if I add those 3 numbers together, so I've got the 0.007, I've got the 0.25, put an O in there just to make it tidy, and I've got the 4.02, again, put a 0 in there just to keep it all lined up. If I add those together, and it's a very easy addition, because I've got 7 here, and then I've got 5 plus 2, that's 7, and then I've got 2, which just goes in there, and then 4. So this is another method that you can use. It's perfectly fine. You use whatever method makes most sense to you. So if it's if you would intuitively count up to the bigger number, especially if all the digits in here were bigger than all of the digits in here, the column method would be fine. It's when you have to start borrowing things because you've got zeros that it can get a bit messy. So if it makes more sense to count up, this is a quite difficult example, but if it makes more sense to count up from the smaller number to the bigger number, for example, if I was doing 9 subtract 8.9, I wouldn't write 9.0 and then 8.9 and then borrow things. I would just count up 0.1 to get the answer. So that's fine if you want to set it out that way. We'll just take some practice. So here's lots of practice questions for you. Have a go at these. Now, although these are written so you just write the answer, type the answer into the box, I would use pen and paper. So use pen and paper to work it out, and then just type it into the box. These start off really straightforward and then get progressively a bit more difficult. So have a go at these. That's just adding and subtracting. Practice makes perfect. Have a look at the Edexcel non-calculator paper ones, and that will give you an idea of the level. I know a lot of people get anxious about arithmetic when they're starting the GCSE maths course, but really, honestly, the level of arithmetic that you need for GCSE maths is not great. You just need to know your times tables, and you need to have an idea of place value, and everything else should fall into place with a bit of practice. So try those questions and see how you get on. Lastly, I'm going to show you a couple of methods for multiplying and dividing decimals. Now, I've already covered multiplying and dividing whole numbers. Just have a quick look at the time, see how much time I've got. Now, there are lots of different methods for multiplying. You can use long multiplication, which is what I'm going to show you here. You could use a grid method. You could use lattice method or Napier method. I'll give you a link at the end. Just stick to whatever method you find easiest. Don't try learning a new method if it's not something you're familiar with. Just do what makes most sense to you and that you're most likely to remember and not make mistakes with. Now, when you're multiplying two numbers with decimals in them, what we do is we just ignore the decimal points. Multiply it as if they were whole numbers and then put the decimal points in at the end. So that's the thing to remember. Don't try to multiply with the decimals in place. For example, if we were asked to work out 65.4 times 0.07, just work out 7 times 654 the way you would normally, and then worry about the decimal points at the end. So set it out like a short multiplication like this. So the way I work this out using short multiplication is I do 7. Again, we're working from right to left. 7 times 4 is 28. So 8 carry the 2. 7 times 5 is 35, plus the 2 is 37, so 7 carry the 3. And then 7 times 6, you need to know your times tables, is 42, plus the 3 gives me 45. So 4,578. That's not the answer. Well, it is the answer to this, but it's not the answer to the question I was asked. I need to decide where the decimal point is going to go. So there's a couple of ways you can do that. You can either use estimation to work out where you think would be a sensible place to put the decimal point. But with this question, I would probably just use the method where you count the number of digits after the decimal point in total. So the way this works is you look at the two numbers. This one has got 1 digit after the decimal point, and this one has got 2 digits after the decimal point. So that means the answer is going to have 3 digits after the decimal point. So by just counting the number of digits after the decimal point in total in the question, that tells me that the decimal point here is going to go between the 4 and the 5. Okay, check it on your calculator and you'll see. So don't forget that step at the end where you need to put the decimal point in the right place. Let's have a look at another example. Now, this time we're going to have to use long multiplication. Again, I'm going to use the traditional method, but if you are used to doing it a different way, either using a grid or if you are using a lattice or Napier method, you can do that as well. So let's go through this method again. So all I'm going to do is multiply 731 by 53 and put the decimal point in at the end. So set it out like this. Remember, I need to do 3 times 731, so each digit in turn. So 3 times 1 is 3, 3 times 3 is 9, and 3 times 7 is 21. No carrying. And then I'm going to do 50 times 731, so put the 0 because it's 50, and then do 5 times each of the digits. So put the 0 down. 5 times 1 is 5, 5 times 3 is 15, 5 carry 1, 5 times 7 is 35, plus the 1 is 36. Then add these two numbers together to get the total. So 3 plus 1 is 3, 9 plus 5 is 14, carry 1, 5 plus 1, plus 2, don't know where I've got 7, is that right? Yeah. 6 plus 2 is 8, and then the 3 here. Now, where does the decimal point go? Well, in my question, I've got a 3 and a 1 after this decimal point, and here I've got a 3. So I've got 2 digits after the decimal point here, 1 digit after the decimal point here. So altogether, 2 plus 1 is 3. So I want to go 3 places in from the end. So that's where my decimal point is going to go. 3 digits after the decimal point, including zeros if you happen to have zeros in there. So my final answer is 38.743. Another way you could do it is you could say, well, this number is about 7, 7 and a bit. This number is about 5, 5 and a bit. 7 times 5 is 35. So we expect the number to be around 35. And since these numbers are bigger than 7 and 5, that does seem to be about right. And that will tell you where the decimal point goes. So you could always use an estimation to work out where your decimal point should go. Okay, how about division? Now, division works in a different way. I can't divide by a decimal number. So what I do is I write the division as a fraction with one number over the other. Now, normally I wouldn't use decimals within fractions, but it works in a similar way. And I think that thinking about it as a fraction will help, especially if you're used to converting fractions. So if we think of this division as a fractional division like this, so 4.13 divided by 0.7. What I'm trying to do is make the bottom number into a whole number. Don't worry about the top. I can divide decimals by whole numbers. I just can't divide decimals by fractions, by decimals. So if I multiply top and bottom of this number by something to make the bottom whole, that will mean I could then work out the answer. So all I do then is I can make 0.7 into a whole number by multiplying it by 10. And as long as I multiply the top by 10 as well, I'm not changing the value of the division. I'm not changing the value of the fraction. So as a rule, so here I'm just going to multiply top and bottom by 10. So that changes the calculation. And you can do this actually for any division. You can, as long as you multiply the top, as long as you multiply both numbers by the same thing or divide both numbers by the same thing, you're not changing the outcome of the division. So we've then converted this into the equivalent calculation, 41.3 divided by 7. And then I can work this out now just using short division. So just set it out in the normal short division way. The decimal points are lined up when we're dividing decimals by whole numbers. And we just go through step by step. So 7 into 4, that doesn't go because 4 is smaller than 7. So put 0 and sorry, I haven't put every step in. So put 0 and carry 4. 7 into 41 goes 5 times. 5 times 7 is 35. So 41 minus 35 is 6. So carry 6 to the 3. Line up the decimal point. So make sure the decimal point goes in the right place here after the 5. And then work out 63 divided by 7. And that gives you 9. Now, if you do get a conversion where it's not dividing exactly, if you've got remainders, you can carry on adding zeros to put your answer to however many decimal places you want to write your answer to. So that's the answer to the calculation. 4.13 divided by 0.7 is 5.9. Okay, so all you're doing is multiplying both numbers by 10 to make an equivalent calculation. Let's have a look at another example. I haven't got another example here, but as a general rule, if you had 2 digits after the decimal point, you would multiply both numbers by 100. If you were dividing by a number that had 3 digits after the decimal point, you would multiply both numbers by 1,000, and you could then just divide by a single digit number. Okay, does that make sense? I haven't got time to do any more practice questions, I'm afraid, but there are more video examples in your course materials. So here are some practice questions. They've also got some worked examples on there. So I would have a look at those on the interactive worksheet. Click that link, make sure it's working. So this is all multiplying with decimals. And this is dividing with decimals, including dividing by 10, 100 and 1,000. So have a go at those. Okay, practice makes perfect. Now, next session, I'm going to move on to percentages. You've also got some videos in your course materials. So if you go to that page, Calculating with Decimals, you will find some videos where I've gone into a lot more detail. I don't have time to do that many examples in these live sessions, but there's some videos on that page, Calculating with Decimals, in the decimal section that will go through the steps for some harder examples. So that's about it from me for today. Practice makes perfect. So if you are finding this hard, really just persevere with doing as many practice questions as you can. The Hegarty Maths has got some really good videos. When you're working through these videos, try to answer the question yourself. So pause the video, try to answer the question, and then press play to watch the answer just to check your work as you go along. This last video, multiplying big numbers and decimals, that demonstrates a different method called the lattice method for multiplication. Which is a good method as well. It's different from the grid method and the traditional method, and you might prefer it to those. So have a look at that and see if you find that method easier. If you go to chapter 7 in your course materials, I'm just going to give you a link there. You will find different place value problems, including ordering decimals, and adding, subtracting, and multiplying decimals. They also cover in that chapter estimating and rounding, and I haven't covered that yet. I'm going to go onto that in a later session. So just leave those bits out for now, unless you're already familiar with it and you want to cover it now. I'll be going through that at the beginning of Unit 2. If you're using this book, I know a few people have bought a copy of this book. There are some practice questions on page 3, page 5, and page 16. As I said, percentages will be covered next session in session 7. If you've got this Success in a Year book, I know some people are using that as well. The first section, 1.2 and 1.3, involves multiplying decimals. And Maths Genie is very good for revision because there's videos, and these are more exam style questions, which hopefully you'll find quite helpful. If you go to the grade 1 section, there's a section on place value right at the top. Addition and subtraction and multiplication and division will all have practice questions in there for you to practice multiplying, dividing, adding and subtracting decimals, and also working with place value in general. Okay, that's just about everything. As I said, rounding and estimating will be covered in session 18. So if you want to jump ahead and try that, you can go ahead in the course materials. It's at the beginning of Unit 2. Next session, I'll be covering percentages. So if you're watching live, I hope you'll be able to join me for the live session then. Thank you to Ailey for joining me today. Thank you for your help. Has anyone got any questions? I haven't been looking at the chat boxes I've been going through. Has anyone got anything that they would like to ask me now before I turn off the webcam? Someone's asking about revision sessions. There will be some revision sessions for the people that are doing the November exams. I've planned 5 revision sessions for grade 4 and 5 topics for people sitting the exams in November. Obviously can't cover everything, but they'll just give you an overview of some of the most crucial topics for those of you aiming for grade 4 and 5. And those will start at the end of September. I'll send a message about that early next week. Okay, that's about it from me then. If you enjoyed the session and you would like to leave me a review, that would be much appreciated. I'll just give you a link there to Trustpilot. Those of you watching live, I will email you all of the links from today's session to save you going through it again and finding the links. And if you need to get in touch with me or your tutor or any of the other students on the course, you can use the links on the Connect and Communicate page. Student services have their details at the bottom of every page on the ICS Learn Student Community if you've got a question that doesn't involve maths. I hope you've enjoyed that session, and I will hopefully see you next time. Bye bye.